See this question. When a metal is irradiated with light of frequency 4.0 into 10 to the power of 16 second inverse, the photoelectrons emitted had 6 times the kinetic energy as the kinetic energy of photoelectron emitted when the metal was irradiated with light of frequency 2.0 into 10 to the power of 16 second inverse. Calculate the critical frequency of the metal. Critical frequency, that means threshold frequency, nu naught we have to calculate. This question comes under photoelectric effect concept. Okay, see, first of all you should read the question completely and we should understand the question clearly. What is the given question? There is a metal, this one strikes with a electromagnetic radiation frequency 4.0 into 10 to the power of 16. 4.0 into 10 to the power of 16 frequency light strikes on metal surface. Then photoelectron is emitted. Electrons are emitted. Let kinetic energy Ke say. Kinetic energy Ke. Now this kinetic energy 6 times. When 6 times, another electromagnetic radiation with frequency 2.0 into 10 to the power of 16. Another electromagnetic radiation with frequency what? 2.0 into 10 to the power of 16 second inverse. Okay, here also electron emitted. Here kinetic energy Ke1 say. Here kinetic energy. So this kinetic energy 6 times of this kinetic energy. That means Ke2 that is equal to 6 Ke1. Okay, so when an electromagnetic radiation strikes on with frequency 4.0 into 10 to the power of 16 strikes on metal surface, the kinetic energy of emitted electron is 6 times of this Ke1. Why? Because here strikes with frequency 2.0 into 10 to the power of 16. Okay, so now Ke2 is equal to 6 Ke1. Now what we have to find? Critical frequency, nu naught we have to find. So what is the equation? Photoelectric effect E is equal to, or we know H nu is equal to H nu naught plus Ke. Therefore Ke is equal to H to nu minus nu naught. Now take ratio Ke1 by Ke2 is equal to H nu1 minus nu naught. Nu naught same. Why nu naught same? Metal same metal, that's why nu naught does not change, by H into nu2 minus nu naught. Ke2 is equal to 6 Ke1. Ke2 is equal to what? 6 Ke1, 6 times of this kinetic energy. Okay, Ke2 is equal to 6 Ke1. That's why that is equal to Ke1 by Ke2 6 Ke1. That is equal to H cancel. Nu1 what? 2.0 into 10 to the power of 16. 2.0 into 10 to the power of 16 minus nu naught. We have to find nu naught by nu2 what? 4.0 into 10 to the power of 16 minus nu naught. Okay, now calculate. So 1 by 6 cross multiplication, then 4 into 10 to the power of 16 minus nu naught is equal to this one 6 2s are 12 into 10 to the power of 16 minus 6 nu naught. Now this one send this side, then minus 6 come this side, plus 6 nu naught to minus nu naught to 5 nu naught. Now 5 nu naught is equal to, now send this side, 12 minus 4 into 10 to the power of 16, 12 into 10 to the power of 16, 12 minus 4 8, so 8 into 10 to the power of 16. Then nu naught is equal to what? 8 by 5 into 10 to the power of 16, that is equal to 8 by 5 1s are 5. Okay, again 5 6s are into 10 to the power of 16 joules. 16, sorry, nu naught frequency second inverse. So what is our answer? 1.6 into 10 to the power of 16 second inverse. Understood? First of all, we should read the question completely and understanding the question important. Okay, now so first one metal is there, one metal is there, one metal is there. Now some electromagnetic radiation falls on it, electron ejected. Now this electron has some kinetic energy. That kinetic energy 6 times of emitted, 6 times of photoelectron emitted when the metal was irradiated with light frequency 2.0 into 10 to the power of 16. Here kinetic energy Ke1, this Ke2 is 6 times of this Ke1. Okay, now next question. In photoelectric effect, if the energy required to overcome the attractive forces on the electron, that means work function of lithium, sodium and rubidium are 2.41 electron volts, 2.3 electron volts and 2.09 electron volts respectively. The work function of potassium K. Okay, we know lithium, sodium, potassium, rubidium all are group elements. All are group elements. See, in the photoelectric effect, energy required, work functions given, work functions, lithium work function given. What is the lithium work function? 2.41 lithium work function. Sodium work function 2.3 and rubidium work function 2.09. Asking what? Potassium work function. Potassium. This is concept based, no need calculation. Concept based. Why? See, lithium size is small. This is smaller atom. Smaller atom means what? The electrons strongly attracted by nucleus. No? Electron strongly attracted by nucleus. So when strongly attracted by nucleus, then more amount of energy required to remove the electron. No? We know more amount of energy required. That's why here more work function 2.41. Comparative to lithium, sodium size bigger. Sodium size bigger means attraction some little less. Then comparatively this one, here work function less. Again sodium to potassium, again size increases. Size increases means less attraction. Less attraction means energy required to remove the electron from the metal surface less. So this value compulsory less than 2.3. This value compulsory less than 2.3. K value compulsory less than 2.3 and compulsory more than 2.09. So potassium value compulsory less than 2.3 and greater than more than 2.9. So compulsory the K value in between 2.09 and 2.3. Why? Because the potassium metal in between sodium and rubidium. Now check the options. 2.52. That is not less than 2.3. 2.35. That is not less than 2.3. 2.01. That is not greater 2.01. So 2.01 compulsory, not 2.01. Why not 2.01? This potassium value, this more than 2.09 and less than 2.3. Then what is the correct answer? 2.2. This is 2.2. Why? Because this is concept question. Some elements work function given. What are the elements? Lithium, sodium, rubidium given. Work function. We know lithium, sodium, potassium, rubidium group elements. We know top to bottom size increases. Size increases means attraction less. Nucleus, valence electron, attraction less. So attraction less means some less amount of energy required to remove the electron. So lithium small atom, that's a more attraction, so more amount will be required. So that's why work function more, 2.41. Comparatively lithium to sodium, work function less. So sodium to potassium, work function less. To potassium to rubidium, work function less. So potassium in between sodium and rubidium. That's why the value should be in between 2.09 to 2.3. So what is the, in the options, what is the value in between 2.09 to 2.3? 2.2. Hence second option is the correct answer. Okay na? Next one. The energy of photon of light having frequency of 3 into 10 to the power of 15 second inverse based on Planck's quantum equation. Energy of photon E is equal to h nu. Again h already frequency given, that's why 6 into 10 to the power of 6 into 10 to the power of 6.625 into 10 to the power of minus 34 joule second into new value given, new value what, 3 into 10 to the power of 15, 3 into 10 to the power of 15 second inverse, second inverse cancel, then see multiply 3 into 5, 3 5s are 15, 3 2s are 6 plus 1 7, 3 6s are 18, 1 3 6s are 18 plus 1 19, 19.875 into 10 to the power of minus 34 to 15. So 34 to 15 then 19, 10 to the power of minus 19 joules, 10 to the power of minus 19 joules, or 1 point. This is almost taken as 9 because in the options given 9, so that's why you can take it as 9. So then 1.99 into 10 to the power of minus 20 joules, 1.99 into 10 to the power of minus 18 joules, 18 joules, 10 to the power 1.9 into 10 to the power of minus 18 joules. Hence first one is the right answer. Got it? Next one, direct formula based. E is equal to h nu, that is equal to hc by lambda, that is equal to hc nu bar, because 1 by lambda is equal to nu bar wave number. Then E is equal to 6.625 into 10 to the power of minus 34 joule second. C value 3 into 10 to the power of 8 meter per second. Nu bar 5 into 10 to the power of minus 5 into 10 to the power of minus 5. Okay, now you calculate this value, you will get answer. Again this value 3 into 6.625 what, already before we calculate 19.875 into 5 into 10 to the power minus 34, 10 to the power of minus 5, 10 to the power of minus 39. So 10 to the power of minus 39 means here 10 to the power of 8, so 10 to the power of minus 31, 10 to the power of minus 31, that is equal to multiply with 5 5s are 25, 2 5 7s are 35, 2 37, 3 5 8s are 40, 43.4, 5 9s are 45 plus 4 49, 4 5 1s are 5 plus 9. Okay, now 99.375 into 10 to the power of minus 31 or 9.9375 into 10 to the power of minus 30 joules. So what is the near value? This is okay, hence third option is correct. Okay, now change the value corresponding to the given options. Okay, next simple question. We know energy directly proportional to frequency, then ratio E1 by E2 is equal to nu1 by nu2 ratio. Okay, E1 by E2 asking ratio E1 by E2 is equal to ratio nu1 given, nu1 what, 3 into 10 to the power of 14, nu2 given 5 into 10 to the power of 14, that is equal to 3 is to 5, 3 is to 5, 10 to the power 14, 10 to the power 14 cancel, then 3 is to 5. Next question, minus 19 joules. The kinetic energy of the ejected electron is 12.0 into 10 to the power minus 20 joules. The work function, asking work function, direct formula h nu is equal to what, W naught plus ke, therefore W naught is equal to h nu minus ke. Okay, h value what, 6.625 into 10 to the power of minus 34 joules. New value given, new value what, the kinetic energy given, photoelectric effect on metal surface, energy given, directly energy given, so that's why Directly you can take energy, work function, energy. So E minus K, energy given 5.6 into 10 to the power of minus 19. Directly energy given. E is equal to W naught plus Ke, photoelectric effect equation. W naught is equal to E minus Ke, 5.6 into 10 to the power of minus 19, minus kinetic energy given. Kinetic energy what? 12.0 into 10 to the power of minus 20. But here 10 to the power of minus 19, here 10 to the power of minus 20. You convert this one to 10 to the power of minus 20, or this one to 10 to the power of minus 19. Now I convert 10 to the power of minus 19 to 10 to the power of minus 20. Then this is 56 into 10 to the power of minus 20. 10 to the power of minus 20 minus 12.0 into 10 to the power of minus 20. Now 10 to the power of minus 20 common. Then 56 minus 12. 56 minus 12 into 10 to the power of minus 20 common. 56 minus 12, 4, 44. 44 into 10 to the power of minus 20, or 4.4 into 10 to the power of minus 19. 44 into 10 to the power of minus 20, or 4.4 into 10 to the power of minus 19. Hence, what is the right answer? Third one. Okay, na? Next question. So in this way, you are doing some more examples given in the material. Okay, in the next class we will discuss spectrum. Okay na, spectrum and different types of spectrum. Okay na, thank you.